So in this video, we're going to talk about density and specific gravity. Okay, so let's first talk about density. Okay, so density, okay, relates to the object's mass and its volume. So the equation really is just mass divided by volume. All right, and so if you know the density of a given object, you could easily figure out what's its mass if you're given the volume, or you could figure out the volume if you're given the mass, as long as you know the density. So knowing the density of a liquid it's important, especially when it is easier just to measure the volume of a liquid rather than trying to measure the mass of the liquid. Okay. All right. So as I said, density is equal to mass over volume. And so in liquids, typically, the units for the density of a liquid is usually grams per milliliter when it comes to liquids. Okay. Now, when it comes to things like solids or gases, right, we typically measure density as for grams per centimeters cubed. All right. Now, just to let you know that 1 milliliter is equal to 1 centimeter cubed. So these two different units are exactly the same size, and it can be used interchangeably. But typically, when it comes to specific units like this, one is for liquids simply because of how it's measured. All right, so the volume of liquids are usually measured with graduated cylinders or volumetric flasks, pipettes. So that's usually in milliliters. While the volumes of like solids or gases, solids particularly, is measured in centimeters cubed, while we're looking for things like, we measure the length times the width times height. And so that's why it's centimeter cubed. So it's all about how the measurement, we come up with the measurement for the volume. That's the difference between the two. Okay. So let's just jump into to example questions. All right. So you guys can see exactly how we use density. Okay, so the first question I want to ask, okay, so what is the volume? So can't spell what. Apologize. So what is the volume of rubbing alcohol? Okay, so rubbing alcohol, would you need or would you use if you needed 20.0 grams? Okay, and so the density of rubbing alcohol is 0.7855 grams per milliliter. Okay, so as I said before, we know that density is equal to mass over volume. All right. Now, there's kind of like two ways you can answer this problem, and I'll show you both ways. You could choose one that you're most comfortable with or makes more sense to you. All right. And so the first way I want to kind of show you is just using this main equation here and just rearrange it so that way you can find whatever you're looking for. All right. So let's just first try to figure out what do we have and what we need. All right, so it asks you or tells you what is the volume. All right, so we're looking for V, all right, of rubbing alcohol would you use if you needed 20.0 grams. So 20.0 grams is your mass, and then I tell you that this is the density. All right, so it's clear that we're looking for V. All right, so I'll rearrange this equation so that way I could solve for V. And when you do that, all right, when you rearrange this equation to solve for V, then you see that V is equal to mass divided by the density. Okay, so now that we know that, okay, so the mass is 20.0 grams, so 20.0 grams will go on top. The density is 0.7855, so 0.7855 grams per milliliter. All right, and so crossing out units, this gram will cancel out, this gram will cancel out. All you're going to have left is milliliter, which is perfect. All right, and so that we find that the volume In this case, if you put in a calculator, will be 25.5 milliliters. Okay, so not too shabby, right? Now, the second way I was talking about that you could do this is using conversion factors, right? Unit conversions, dimensional analysis, or factor labeling. So make sure you kind of look at that video if you're still in question on it. All right, but let me show you how this works. All right, so here, if you notice, you're given a conversion, or you're given a equivalent statement, right? So in this case, when we're talking about this case for density, it's saying that you got 0.7855 grams equals 1 milliliter. That's your equivalent statement. Now we could change this into two different conversions. All right, the conversion could be either 1 mil over 0.7855 grams, or let's flip it, 0.7855 grams over 1 mil. Now, depending on the question, depends on which conversion factor you use. So since they said that you're starting off with 20.0 grams of rubbing alcohol, okay? Now we have to multiply this by a conversion factor. We got to use the units to help us figure out which conversion factor will best answer this question, okay? So because grams is up here as a numerator, you want to cancel it out, all right? And so that means you want to make sure that we have grams on the denominator, and we're looking for volume, so we want milliliters on top. So which of these conversion factors give us that? Well, hopefully you notice it's going to be this one. And so that's the one I'm going to write. So 1 milliliter divided by 0.7855. Okay. And so it's 20.0 times 1 divided by 0.7855. And once again, you will get 25.5 milliliters. So that's the way that you could work through this type of problem. Now, let me give you another example. So let's say you have a wooden block, right? So you measure the dimensions of the wooden block, and the dimensions of the wooden block turns out to be 12.5 centimeters length, right? So that's your length. 6.5 centimeters, that would be your width. And then you got 8.3 centimeters, and that's your height. So these are the dimensions of your wooden block. And then you find that the mass of your wooden block is 245.0 grams. So now the question is, what is the density of this wooden block? All right. And then I'm going to ask another question, a second question, okay? So would this block float on water? All right. Will this block float on water? Okay. Let's figure this out. Well, as I said before, we know that density is equal to mass over volume, right? Now, if you recall that a volume of an object, all right, is mass times length, it is length times width times height, right? And so that's what we have here. All right, we have the length times width times height. And so if we multiply these three together, 12.5 centimeters times 6.5 centimeters times 8.3 centimeters, we multiply those three together, you're going to find the volume, all right? And so in this case, when you multiply these three, you get 674.375 centimeters cubed. That's our volume of the wooden block, okay? We know what's the mass, okay? And so all we have to do is just take the mass, all right, and then divide it by the volume, which we just figured out down here. So that's your volume that I'm going to place here. And so this is going to allow us to figure out what's the density overall. So let's go ahead and plug this in. All right, so once again, we're looking for density. Our mass is this 245.0 0.0 over, we know what's our volume. It is 674.375. All right, and so you put this in the calculator accordingly, and then you find that the volume, or the density, I'm sorry, for this wooden block is 0.3 6 grams per centimeters cubed. This is our density, all right? So now the question is, the second question I ask, will this block float in water? Well, what do we know about water at room temperature? Well, water is going to be roughly at room temperature 1.00 grams per centimeter, or actually per milliliters, because water is a liquid. Okay, so 1.00 grams per milliliters. All right, so we see here that the wooden block is less dense than water. All right, because that's the density of water. And so if it's less dense than water, then we should expect that this wooden block will actually float on water because it's less dense than water. Now, if the wooden block was more dense than water, then we expect it to sink towards the bottom. But this is not the case in this scenario. Okay? Now, the next thing I want to talk about is specific gravity. Okay? Now, for many real-world applications, it is more convenient to use specific gravity than density, all right? The specific gravity of a substance, which is typically most times in its liquid state, is simply the, all right, so this is equal to, is simply the density of the substance divided by the density of water when they both are at the same temperature. And so that part's really, really important. Okay, so let's just jump right in so you can see how we could ask these type of questions and use this equation here basically. All right, so you have methanol. So methanol is CH4OH. A has a specific gravity, so its specific gravity is equal to 0.7930 at 20.0 degrees Celsius. All right. So the question I want to know, or what I want to figure out, is what volume of the 100 grams of methanol, and what is the volume of 100 grams of methanol at this temperature? All right, at 20 degrees Celsius. Okay, so like I stated before, we have specific gravity is equal to the density of the substance divided by the density of water, as long as they're both at the same temperature. Okay, so the density of water in this case, all right, so density of water at 20.0 degrees Celsius is equal to 0.9982 grams per milliliter. All right, so now that we know that, the question asks you, what is the volume, okay, of methanol, okay, when you have 100.0 grams of it? And then I tell you what is its specific gravity. So I gave you the specific gravity. I've also given you the density of water, okay? And so when you're looking at this, it's like, okay, it's clear to what I didn't give you, okay? And I didn't give you the density of the substance. Now, the cool thing is that once we get the density of the substance, which you already know that density is equal to mass over volume, okay? And so since I'm looking for the volume of this substance, I can use that's the second equation to help me figure this out. But first, I need to know what is the density of the substance, okay? And so if you're looking at this first equation here, specific gravity equals the density of the substance divided by the density of water, all right, I'm going to rearrange this equation so that I could get density of the substance by itself, because that's what I kind of really need, right? And so what you'll see is that the density of methanol, in this case, the density of methanol is equal to, all right, so I'm rearranged the specific gravity of methanol times the density of water, in which we have them both, right? So the specific gravity of methanol, it says, is 0.7930. So 0.7930 times the density of water, all right, which is 0.9982. So 0.9982 grams per milliliter. All right, and so when you put this in the calculator, you find that the density of methanol is equal to 0.7916 grams per milliliter. So that's our density of methanol. Now that I know that, I could use this equation here to figure out what's my volume of methanol, right? Because, hey, now we know density, great. We also know what mass are we looking for, and that's 100 grams, okay? So let's rearrange this so that we're looking for the volume, okay? And so we know that volume is equal to mass over density, okay? So your mass, once again, is 100 grams. Your density is 0.7916 grams per milliliter, okay? And so when you plug this into the calculator accordingly, you will find that the volume is 126.3 milliliters. And so that is the volume of methanol that you need in order to have the mass of 100 grams.